So, just a reminder, we've defined data science as using math and data to build models that make predictions. Now, let's talk about the math. And I use the word math here intentionally because you've probably heard algorithms, quote unquote, tossed around a bunch. And here's where we introduce them, but just in the context of basic math, nothing more. So, let's start with a basic and very real example. Your company has insured the levees around a coastal Japanese city. How high do you wish the walls to be? And remember, if the flooding goes over the walls, you have to pay for it. So you might gather all the historical data on floods, then find the highest previous water level or watermark, and then multiply that number, the previous highest level, by some factor, right? Just to be safe. That would be a kind of common sense and historically accurate approach to building to or to ensuring the height of the walls. And now in this instance, our algorithm or steps we follow to build a model, this is model reflects our prediction, is very simple. We take the high water mark, and then we just add some more to it just to be safe. Now, let's say in a different example, we work the concession stand at the local high school. We want to predict how many hot dogs we need to make for each game and make during each game. So, how much inventory do we need to bring? After a few seasons of fluctuating hot dog sales, you gather data on hot dogs sold and you compare it to the scores of the game. And you notice something interesting. When you plot the data, you see a correlation. It's not perfect, but it's there between how close the game is and the number of hot dogs sold. Now, this makes sense to you as someone who watches football because if it's a close game, people stick around and some of those people get hungry. Okay, but you need more than that for your hot dog stand. You want to know how many hot dogs to make based on a given point spread. So you need an input of the score, and then you're going to decide how many hot dogs to make. And looking at these points on a graph, you think it shouldn't be too hard to draw a line through it to give you that number. The line won't be perfect. And in fact, it might not touch any of the points on the graph, but it's the best fit for the data. So given an input, a point spread, the score is 17 to 16, you should then be able to know on the y-axis how many hot dogs to make. Now, and the math to draw that we use is called a linear regression, or there are types of math to do linear regression, where we draw a line that minimizes the distance between the line and all of the points on the graph. So, what is the line that is closest to all of the points, even if it doesn't touch any of them? That's our line of best fit. Now, you're thinking, Gus, this is some really basic stuff. Self-driving cars aren't using linear regressions. I don't know much more than that, but what is really going on here? And that's true. The algorithms, read the math. We're going to cover later, or at least the types of math are going to get a lot more complicated. But all you need to understand, I want you to take this with you. All you need to understand is that they're plotting a course or a line of best fit. None of this stuff is all, or this stuff isn't usually linear, but they're plotting this course of best fit through the data. And while we can easily visualize a 2D line of best fit, and that's why I bring it up to begin with, it's much harder to visualize that when there are hundreds of dimensions. And that can be the case. So your computer can do this with the right algorithm. It won't have that visualization problem. Think 2D line graph though, and you'll be in the right place. And lucky for all of us, the most popular new algorithms, TensorFlow, PyTorch, Keras, and whatever else comes out in the next 6 months, have all been released as open source. They're freely available for us to use. And they can do this for us. So you might ask then, wait a second, why would Google in the case of TensorFlow release it for free if it's so powerful? And why wouldn't they just sell it, right? You're telling me it does this amazing thing. Well, the answer is that the answer is in the final part of our data science definition. It's the data itself. As we'll cover in the next section, the data we use is far more powerful than any algorithm and really is the driving point of our accuracy. So stick around for the next section on data.